In this problem, we're told the propeller of a World War II fighter plane is 2.3 meters in diameter. A. What is its angular velocity in radians per second if it spins at 1200 revolutions per minute? B. What is the linear speed of its tip at this angular velocity if the plane is stationary on the tarmac? And C. What is the centripetal acceleration of the propeller tip under these conditions? Calculate it in meters per second squared and convert it to multiples of g. So what we have here is this plane, and basically we're given the diameter, which is 2.3 meters. And so we're going to be using the radius to solve this instead of the diameter. So the radius is just half the diameter, so just keep in mind that the radius is 1.15 meters. So now that we know that, we can just go ahead and start. So starting with A, we're going to be finding the angular velocity in radians per second if it spins at 1200 revolutions per minute. So they give us the angular velocity, but they give us it in revolutions per minute. So what we're going to want to do is convert from revolutions per minute into radians per second. So in order to convert, let's just start with the minutes. So we know that for every 1 minute, there's 60 seconds. So that'll cancel out the minutes. Now we have it in revolutions per second, but we need it in radians per second. So you need to know that there's 2 pi radians for every single 1 revolution. So if we want to convert from revolutions to radians, you just multiply by 2 pi. Because notice that's going to cancel out the revolutions. And now we have it in radians per second. So 1200 divided by 60 is just 20, and then 20 times 2 pi is 40 pi. So it's going to be equal to 40 pi, and then it's radians per second. So 40 pi radians per second. That's going to go ahead and be your answer to the first part. Now let's move on to B. So B is what is the linear speed at this angular velocity? So we're going to be solving for velocity v, and the formula we're going to use to do this is v equals omega times r. So the velocity equals the angular velocity times the radius. So keep in mind we're doing it at this angular velocity of 40 pi radians per second, and we know the radius is 1.15. So all we have to do is just plug it in. So the angular velocity is 40 pi, and then we multiply by the radius, which is 1.15. So 40 times pi times 1.15 is 144.513 and so on. I'm just going to round to 144.5. So 144.5, and then we measure, or the units for linear velocity is meters per second. So it's going to be about 144.5 meters per second. That's going to be your answer to B. So for C, now what we're trying to do is solve for the centripetal acceleration. So the way we do that is by using this formula. A sub C is equal to omega squared times r. So we're going to be finding the centripetal acceleration at the same angular velocity. So 40 pi radians per second. And then we just plug in the radius, and then that'll give us what we're looking for. So omega is 40 pi. So 40 pi squared multiplied by r is 1.15. So go ahead and plug this in. 40 times pi, or 40 times pi squared, and then multiply it by 1.15. So when you go ahead and do that, you're going to get it equals 18160.0721. And keep in mind this is going to be in meters per second squared. So meters per second squared, but they want us to convert it into multiples of g. So basically 1g is equal to 9.81 meters per second squared. So we just got to basically divide by 9.81 meters per second squared, which is equal to 1g. And then that'll just cancel the meters per second squared, and we'll have it in g's. So do this right here, divide by 9.81. And so when you go ahead and do that, you're going to get 1851.179 and so on. So it's just 1851, and then the units are g. So 1851 g, that's going to be your answer to C. So this was C, this was B, this is A. And so yeah, these are your answers, and hopefully you found this useful.